So we're going to switch back over to looking at a couple questions, apparently from the homework from yesterday, before we look at reviewing for this mid-chapter test, which is based on this mid-chapter quiz. So I'm going to scoot it back. What page was that on? 194? Really? I had already logged in.
I think it was 96. I guess.
You think it was page 196?
Yes.
The homework I think that he was asking about was from lesson 2.
Oh, the homework?
Yes.
That was 184.
Let me leave this. Okay. So 3, 3, you're right. Let's go 184. Okay, perfect. So 27, 29. We're looking at these questions right here, 27 and 29.
Numbers. Oh, yeah.
Okay, this is page 184, which is homework questions from lesson 2. So you weren't sure where to go on this. What do I know about these angles here? So that isn't quite what I think it is.
That's added to 180.
No.
Oh,
that only works if we have parallel lines.
Yeah.
Okay? So these two are not going to add up to 180 because these two lines are not parallel. But you notice that here, these two have these that show that those two are parallel. Okay? When you have two parallel lines cut by a transversal, that's what this is right here. This line is your transversal, cutting your two parallel lines. Okay? What that means is these two, this one here and this one here, are known as consecutive angles. Now, consecutive angles, they do add to 180. Okay? So I can take this 2x and 96 and have that equal 180, and I can solve for x.
Oh, yeah.
And then once I have that, what do we notice here? Well, we still have these two parallel lines, okay, cut by this transversal. So 94 plus 3y plus 44 equals 180. I can solve for x, I can solve for y. Doesn't seem too bad now, right? Okay. And so it tells us to explain the reasoning, which of course they didn't necessarily explain it in the book, but I'm telling you it's because of those consecutive angles, right? Okay.
I understand
what you're looking for is this theorem 3.2, consecutive interior angles theorem. If two parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. Okay? So in order to explain the reasoning, you can say that theorem 3.2 states, there's your reasoning. Okay? Here we also have parallel lines, right here. Okay, we have two different transversals. We have this one, and we have this one. Okay? Checking to see which angles we actually have here. It looks like...
I know how to do 29 now.
You know how to do 29 now? We don't need to spend the time?
I didn't know about the parallel thing.
Ah. Okay, every time that you see this, you see that you have parallel lines. Anything that cuts across these parallel lines is known as a transversal. Okay? So that's what we're looking for. Are we ready to move on to the review? Or is there any other questions? Review? Okay, not a problem. So I think the review was like 194, 196? Yeah, 196, 197. Okay. I admit, do I remember what the exact theorems are? No. For me, just like you, I'm using that cheat sheet. I'm looking up, I know that that is the way that it is and why, but I don't remember the numbers. Okay, I have to look up, is that a theorem? Is that a postulate? This is not something that I keep in my head, not something I expect you guys to keep in your head. Okay, so this is page 197, where we're looking at this mid-chapter quiz, which I'm using as a mid-chapter review. Okay, your test that you'll have on Thursday, very similar. I think I technically have like 19 questions, but basically most of these questions are worth like 5%. If there's a couple parts to it, you know, that might be worth 10%, but it's going to look very, very similar. Okay, and so that's why you're going to have to be careful. Okay, just like last time, it's going to be open book, open note. It's going to be using the same images in a lot of cases, but I don't ask the same question. But if you know how to do these, you should know how to answer for the other angles. Okay? So our very first questions, 1, 2, 3, and 4, ask us to identify the transversal connecting each pair of angles. Okay? So right now, we can see that we have these lines and these lines, okay? These appear to be parallel. These definitely do not, okay? We need to classify the relationship between each pair of angles. We have to say whether it's alternate interior. What does it mean to be alternate?
You're on different sides of the line.
Different sides of the line. Interior?
On the inside.
On the inside, between two different lines. Alternate exterior, well, different sides,
Outside.
and on the outside. Corresponding.
Same side?
Yeah, it's kind of like that same location, like it has to be on the same side, both,
So like 5 and 8.
yeah, no.
I thought it
Corresponding
would be like 6 and 14.
would be like 1 and 3.
Oh.
10 and 12. They look like they're in the exact same location,
So
except
instead
for
of
I just
5 and-
shifted down.
Instead of 5 and 8, it would be 5 and 7.
It would be
Yeah.
5 and 7. Agreed. Okay?
This is alternate interior.
And then consecutive interior is where we go right next to each other. Those are consecutive. Okay? These are consecutive. Actually, sorry. Really, it's going to be on the same side of the transversal. These are transversals. This is actually not. This is one of the parallel lines. So these are consecutive interior. These two are consecutive interior, but it doesn't work this way. Does that make sense?
Yeah.
Okay, because this here is one of your transversals. This here is one of your transversals. And these two are your parallel lines. So, if I look at angle 6 and angle 3, what are they? Out of those 4 choices,
It would be alternate interior.
Yeah, that's what I said.
okay, alternate interior. And how about
Okay.
number 2?
Wait, is that right?
Sorry, is 3 interior? Angle 3 is that interior?
3 is interior. It's between the parallel lines.
So I got-
Interior means
Okay,
between the
okay, that
parallel
makes
lines.
sense.
I got it right.
Yep.
Okay.
Okay. Angles 1 and 4.
Yeah. No. Corresponding.
No, they're
And
not
then
corresponding.
14.
Consecutive exterior?
There is no such thing.
Oh, I'm not.
Yeah.
Alternate exterior. Okay, 10 and 11.
Oh, wait a minute.
That's
Oh,
That's
consecutive. Yeah, consecutive interior.
This is consecutive interior. And then 5 and 7.
corresponding.
Corresponding.
Wait, so why was it number 2 corresponding?
Why was 2 not corresponding? The 1 and 14?
Oh, you said 1 and 14. I thought it was 1 and 4. You
Either
said-
which
you had
way,
circle
it wouldn't
4.
make a difference. 1 and 4 still would,
Oh, yeah, we need to be 1.
corresponding needs to be on the same side of the transversal and on the same side of the parallel lines.
Are you gonna give us any problems where like two angles don't have any relationship?
I don't believe so.
Miss Lisa, I have a question.
Yep.
On this example sheet, it makes it seem like, okay, it says 1 and 7. I thought it was only allowed to be opposite on that side. It had to be on opposite side of the transversal.
Okay, for the exterior?
Yeah, alternate exterior.
Okay, exterior just means, quite literally, this is exterior, this is exterior, 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 exterior. The only ones that are really interior,
Oh, the 4 that's on the inside.
Yeah.
Between the 2 lines. Anything that's between the 2 lines.
But,
yeah,
One side.
But it makes it seem like on alternate exterior, they have to be on opposite sides of the transversal for it to be alternate exterior. And that's what I would think.
alternate exterior are non-adjacent exterior angles on opposite sides of the transversal. So this is the
Oh.
transversal,
So would
for
1 and
1
4?
and 7. No, because they're 1 and 4 on the same side of the transversal, the
I'm talking
transversal
about
is 2.
on that example.
Oh, on this one?
Yeah.
Yeah. It's not like I don't think it's true.
No, because they're not, this is the transversal.
Mhm.
It would be like 1 and 8 or 5 and 4.
Yeah, that's what I thought you said that 1 and 4 would be alternate exterior.
If I did, I'm sorry, but I don't see when I said that.
Heard or something.
That's possible. I could have said 4 instead of 14.
So in this
Yeah, 'cause you
situation,
said before.
14.
What was that?
Sorry. So in this situation, 14 is exterior.
No, 14 is interior.
So it's not truly an alternate exterior.
Okay, hold on. You're right. You're right.
Anything
Let
that's
me see why my brain is doing the wrong thing. Because I understand your question now.
Because I think alternate exterior is the closest you could get to like.
Yeah, in this case, it may not be that. So, they tell us alternate interior for number 1. They do say alternate exterior for number 2. Consecutive interior for number 3. Corresponding for number 4. So, they're giving us what we said.
Oh, I see why.
We're looking at 1 and 14.
It's because if you can't go side by side, then they're using the transversals to determine the interior.
And they're still saying, hey, this is on the opposite side of this line, and they're on the exterior of where these two lines are.
Yeah.
So they're calling that alternate exterior.
So if you can't go side by side, then you have to change it and say that, and you
Yeah.
have to go on the outside and say interior and exterior.
But these were good questions, guys. I do appreciate that. Okay, let's look at the next section. Okay, for these next 3 questions, we're going to be using this box diagram that you see right here. Okay, this. It says refer to the figure to identify each of the following. Now again, this shouldn't be too difficult. We need to identify a plane that is parallel to the plane ABCD. So ABCD is this plane up here. What plane is parallel to that?
G, H, E, F.
G, H, E, F. Okay. How about a segment that is skew to segment GH, and it must contain point D. So here's GH. What segment is skew and contains point D?
DF.
What is
Okay.
It's basically if
They
you have
don't
a
intersect,
line.
they're not coplanar.
Yeah.
No.
They don't intersect, they're
Yeah.
not coplanar, and so like literally, this line over here is skewed to that and contains D.
Yeah.
This line over here is also skewed, but it didn't contain D. Do we have any others?
No.
I mean,
No, we could do this one,
Yeah.
skew. Like there's usually a lot of different skew lines. It's just something where like you'd have like straws crossing in the night, but they never touch each other. Okay? What are all the segments that are parallel to HE?
GF.
GF.
Okay, so HE is this one right here. I heard BC,
GF.
GF,
AD.
AD. Any others?
No.
That covers it, right?
Yeah.
Everything else ends up intersecting or is skewed. Okay? So again, not that difficult. And you know, when we're doing things on the computer, obviously we have difficulty with this. I wish that there was an overline, you know, as an option. I always just write out segment BC in order to show that. Okay, let's look at number 8. Now, number 8, simple multiple choice. Which term best describes 4 and 8? 4 is right here, 8's right here. Alternate exterior.
Corresponding.
No. What?
So I have one for alternate exterior, one for corresponding.
It depends on how you look at it.
Because
Because if you're looking at it,
yeah,
if you're looking at it like
corresponding.
straight up, it could be alternate exterior.
Any other votes, or we're just trying to vote between the two?
I'll go corresponding. I'll vote corresponding.
What does it need to have to be corresponding? Same side of the transversal,
Yeah.
same side of the parallel lines.
Yeah.
Yeah, it's alternate exterior.
Same side of the transversal, same side of the parallel lines. Oh, sorry, I circled the wrong one.
Okay.
Corresponding. This is corresponding. You know, when it looks like, you know, someone just shifted right over, but it's the exact same angle, same position, but they just like sidestepped, that is corresponding.
are you drawing these figures off? Then you double guess. The way they draw them, it looks like it looks weird.
Looks confusing. You just
Yeah.
gotta be patient with it, I think. More than anything. Okay, let's look at 9, 10, 11, 12 here. Okay? So this is all together. Here they say in the figure, measure of angle 4 is 104 degrees. And the measure of angle 14 is 118 degrees. We need to find the measure of the angles that they asked for and tell which postulate or theorem that you used. Okay? So if this is 104, can you tell me what number 2 is?
Would it be 104?
It is 104. Why?
Yeah.
Because it's at like the same.
This is where it's really helpful to have your cheat sheet ready, right? We know that this is a, what kind of angle? Well, what's the relationship? They're corresponding. Okay, so you grab the cheat sheet, and we're looking at the cheat sheet for the corresponding angles. Corresponding angles postulate. So this is where you need to hunt for. Where's the postulate or the theorem that has to do with this? Postulate 3.1 is the corresponding angles postulate that says if two parallel lines are cut by transversal, then each pair of corresponding angles is congruent. That's why number 2 is 104. Okay, how about number 9? What is that angle going to be? Do we have a way of figuring that out? Ooh.
14
That's-
is
I think that's 104 again.
You think it's 104?
No,
No, it's not.
no, it's not. No, it's
No.
not.
Doesn't feel like
I
104
think
to
it's
me.
118.
You think that
62.
this angle is the same as that angle?
It's 62, I think.
Why did you get 62?
I'm saying if I'm
How did you get 62?
okay, because 14 corresponds to 16, and then 16 and 9
Okay,
would have to
14
add up
to
to
16.
180. So,
He says that this is 118 because they're corresponding, just like this one was.
and then you would subtract 118 by 180, and you would get 60.
Okay, so we're using postulate 3.1 again. And what is this one here? Where we have, I think in this case, if we just make use of the linear pair, what else do they suggest here? They actually used a different way of doing things. They were using vertical angles as well, which we didn't do in our case. Ours works too. Okay, so what is 10? Ten's pretty easy.
Oh, yeah.
Yeah, 10 is actually 118.
Why?
Because using the 16, we know that's 118.
Yeah.
And
it's-
16 and 15 have to have 180, so
So vertical angle theorem.
180 minus 118.
Agreed.
We get 62 for angle 15, and then we do.
Well, we don't even need that.
We're-
Just the
we're not-
vertical angle theorem says that if it's a vertical angle, it's congruent.
Oh.
But I agree.
Well, I'm
You
also
can
being
do it your way, Nathan.
Okay.
It's just the fact that you added some extra steps in there that were valid. but weren't absolutely necessary.
For the sake of it. We'll also be able to use 3.1 because those are alternate interior, right?
Yeah, yeah, okay, so here's another one. And Richard says, well, hey, this was 118, and we're looking for 10. I can say, well, this is an alternate interior angle, so it's still 118. There's more than one answer. Like, there's still, like, I guess really there's the same answer, but there's different ways to get there. And as long as the path is valid, it doesn't matter how you get to the other side. You know, obviously it's nice to do it in like a step or two. You don't want to take 10, but if it takes 10, it takes 10. Okay? None of them will be counted wrong as long as every step is valid. How about number 7? We're getting kind of crowded in here, right? What is number 7? We know what 2 is. We know what 9 is. We know what 10 is. Can we find 7? There's multiple ways to do it, right?
76.
What did you get?
76.
Okay, how'd you get that?
I did 104 minus 180.
Or the other way around, 180, subtract 104?
Yeah.
Okay, so he could find that that was 76, and because this is 76, this is 76. So once again, we made use of a linear pair and our corresponding angles. Again, just like you saw on the last one, there's multiple ways to get it done. There isn't just one answer and one answer only, other than obviously it is that number of degrees, but how you go about proving that and finding that answer can vary. Okay, there's more than one way to get that done.
What type of angles would 4 and 7 be?
4 and 7. Okay, I'm gonna erase this so I can actually see better. We have so much in there. 4 and 7. I don't think that they're necessarily related.
Okay. Alright.
Well, because they're on the same side of the parallel lines, but they're alternate from the transversal.
Okay, I think I
And I can't count them as alternate interior or exterior. Like alternate has to be interior or exterior, and we have one of each.
I get it.
And they're not corresponding because they're not on the same side. Okay, let's look at 13. Says find x. They give us this and this. How does that help us?
They are.
There's a couple ways you can look at it.
They're alternate exterior.
They're alternate exterior, which means that they're congruent. So 3x minus 9 is equal to 25x plus 15. Can you solve for x?
Yeah.
Should be able to. Put all the x's to one side, all the numbers without the x on the other side, divide, and you'll get your answer for x. Okay, in this case, we didn't have to find what the angle was. All we had to do was solve. Okay, for the sake of time, do I remember what, until 9:30? I'm actually going to skip over 14 and let you guys know that honestly, I didn't put a big word problem like this for a test. I don't want to spend the time on it.
Neither do
I didn't figure anyone would be upset with me. Okay. So here's where we're at.
Ooh.
Determine whether line XY and AB are parallel or perpendicular or neither. And then they say graph each line to verify your answer.
That's a lot of
Okay, so this is what we have. So don't give us any figures. We just have to determine if they're parallel, perpendicular, or neither. So how do I go about doing that? What allows us to see if they're parallel or perpendicular or neither without even graphing them? We learned about this
Slope.
yesterday. The slope. Gotta find the slope. Okay? So AB was one line, XY is the other. So first off, I gotta find the slope of AB. M of AB is rise over run, which is -5 subtract 0, and 4 subtract 2. So that's -5 halves. Okay, the slope of XY. 8 subtract 3. -5 subtract -3. 8 subtract 3 is 5. -5 subtract negative, so that's adding 3. So we have -5 halves, -5 halves. What does that tell us?
It's the same.
It's the same, so what does that mean?
parallel.
They're parallel. They're parallel because they have the exact same slope. So if we're to graph this, I don't know how much room I need. Where did I put my, who knows?
The towel?
Yeah, I dropped it. There we go. Trying to make sure we have enough room. So 2, 0. 1, 2, 0. That's point A. 4 and -5. So there's one line. Now, no, this isn't exactly exact with what we're doing. -3, 3. And then -5 and 8. And I'm going to run out of room here. So roughly there. And you should be able to see, with my limited capabilities here, that they're parallel. Okay? Let's look at 60. Same sort of thing, but we just have different points. So we have to find the slope of both lines, XY and AB. Slope of AB, we have -9 subtract 1, and 6 subtract 1. So that's -10 over 5, which is the same thing as -2. The slope of XY. -4 subtract 10, and 7 subtract 4. We have -14, 7 subtract 4 is 3. Is there any relationship?
No.
It doesn't look that it's the same slope, so we already know it's not parallel. Is it possible it could be perpendicular? What do I need to do to determine if it's perpendicular?
Graph. You gotta put it on a graph.
I need to what?
You can put it on a graph.
I could. What other way though? There's one other way that we learned about yesterday.
Yeah.
What I can do is I can take these two slopes and multiply them. And I get positive 28 over 3. Does it help us? Not really. What number does it need to be in order to be perpendicular?
2. Oh, we know.
It is perpendicular if the product equals -1. That means that they would be the inverse of one another, and so they're perpendicular. Is this equal to -1?
No.
No. So this is neither. It's not perpendicular nor parallel. Okay, let's look at 17. Okay, line 17. Oh, I still need that graph from up above. Okay, so we have this graph in the book, and it gives us certain points. It tells us what this point is, what this point is, what this point is, I think. Sort of. I'm trying to like match up what they say. It's not quite making sense. Okay, so we have these lines. We first off have to figure out the slope of line L. That's this one right here. So in order to determine this slope, we have these 2 points that we can use. Okay? I tend to say 0.1, 0.2, moving from left to right. So the slope of line L is equal to rise over run, which is my change in y, 9 subtract 0, and my change in x. -4 subtract -10. 9, -4 subtract -10, so that's the same thing as adding 10. So this is going to be 6, which is 2/3. Oh, sorry, wrong way. This should be 3/2 or 1.5. Okay? To find the slope for the line that's parallel to M. How am I going to find the slope of the line parallel to M? Guys, we still have 5 minutes. I'm kind of surprised that no one's choosing to write it down. How am I going to determine 18?
From what we have right now.
Yeah. How can I find a line that's parallel to M if, like, we don't have any other lines that are parallel to M?
We'll make our own line.
Do you understand what they're asking?
I don't.
You don't?
I don't know.
For a line to be parallel to M, it's going to have the same slope, right? That's what we learned previously above. Same slope means they're parallel. So if we find the slope for M, we find the slope for the parallel lines. Any parallel line. okay? 19, a line perpendicular to n. Well, again, we don't have any lines that are perpendicular, but we do know that the slope of perpendicular lines is what?
-1.
The product of those is -1. Okay, so all we have to do is find the slope of m. And then the parallel line will have the same slope. Make sense? And for perpendicular to n, it's going to be the inverse of the slope of line n. Because the only way we can get that negative thing is, that's actually going to be the negative inverse. Product of the two slopes equals -1. Do you need me to go through and do those particular ones for you, or would you prefer me to do the last one? Because we have 3 minutes. I know, it's kind of a mess all the time, huh? So if I'm trying to find the slope of a line that's parallel, it's going to be the exact same. If I'm trying to find the slope of a line that's perpendicular, it's going to be that negative inverse. The product of the two slopes will be equal to -1. And then we end up with what we ended up with pretty much yesterday, where we have some sales, and we need to figure out the rate of change in order to predict our new sales. So here, okay, we have sales per year. Sales is our Y. So my slope is Y2 minus Y1 over my year, X2 minus X1, 60,000 divided by 3, so 20,000 in sales per year. Does that make sense?
Yeah.
So if that rate of change continues, what are going to be the sales for 2020? Well, I can add 20 for 7 years, or I can put the 20,000 here and substitute in the correct numbers there. Okay? I think we're pretty confident, hopefully, for this test that comes up on Thursday.